What's up, fam? Everything's different, as you can see. I hope you can still hear me. Not everything, just the location of the camera is the only thing that's different. On time crew, always on time. Mr. Demon Wolf, you made it first. Congratulations, you got the #1 spot. How you doing? What's up, MG? Good to see you. Sharky, what's up, bro? We gotta get some Warzone games in. Maybe not until the end of the week is up for me, but we do gotta get some Warzone games in. What's up, Justin? All last week catching up. Perfect, excellent. Tonight's gonna be fun, so I'm glad you were able to catch up. Tonight we're just gonna relax and have a little fun. If you've already seen the slides, you probably see a little bit of fun stuff in there. Things are going pretty good over here. Good day, just after being off of work for 4 days straight and not really thinking about work, it was it wasn't too bad. Kind of hopping in today, a lot of stuff to catch up on, but all good. What's up, Magookin? I love the name, I love it. How you doing? What's up, TD Roque? Sandpaper, good to see you. Diarrhea, good to see you. All right. Oh, perfect. They said it would be there by end of the day today, so I'm glad you're able to get it. Absolutely. There's still one more left, and there will be. I was actually planning on going to Micro Center pretty soon. They have a bunch of stuff on sale right now, like a bunch of cool little project things. But again, I told you I'm working on a lot of stuff. So I'm working on some bigger and some better giveaways as well. Oh yeah, I mean, so I got to be honest with you. The packing job, I literally went to FedEx and I was like, look, I need you to ship this stuff off and I need you to pack it for me, because I sent off those two things and I sent off a computer to someone. I had some old ThinkPads sitting around, and so I was supposed to get them out a while ago, but during this time a lot of people were without computers when everything kind of first happened. So I found someone on Twitter to give it to. It took me forever to get it to them, but I was able to get those things shipped out yesterday as well. So I'll thank FedEx, and I will continue to use FedEx if they're going to do it for me. They made my life really easy. Last time I went to FedEx downtown, they gave me the stuff to pack it up. This time the guy was like, nah, I got it, I'll just take it. So excellent, I am glad about that. A new phone case, that's dope. I need a new phone case, but I'm holding off because I'm getting deeper and deeper into this biking thing. The cycling thing is something that I really enjoy. I used to mountain bike, and I knew I liked biking, but now that I've kind of expanded my world a little bit, I'm looking at all these bike accessories, and so I'm going to be bike commuting, so I might have to get a case specific to something that's going to allow me to put it onto my handlebars, but I'll figure all that out later. But tonight technically is Intro to Algorithms 2, but you'll see in the slides that I did a strike through and renamed it a bit. And the reason why I renamed it a bit is because, yes, we did an introduction to algorithms already. And while this is going to be the same, a lot of people, as soon as you start talking about algorithms, already have an understanding in their mind of what they hope to learn. And I think that I did a bad job of expressing what it was that we were going to learn in the algorithm section of at least this beginner course. This is only an 8-week course, and from the things that we've learned, you might be expecting that, when you hear algorithms, especially part 2, you might say, all right, now we're going to be diving into those other data structures you were talking about, those other data structures that are not that aren't really data types, and linked lists and things like that. Yes, those things are great, and those things will be learned, but those are actually good for pacing. Those are actually going to be in the second piece. Tonight is going to be more so learning, just getting more practice solving problems. It's something we haven't really done yet. We haven't really sat down and run through problems. We haven't worked through a lot of things. We've been learning topics, we've been learning concepts, but we haven't really built anything or worked through anything. So tonight is going to be mostly that. Now, I did give you there should be a couple things that dropped. I think some things just dropped, a number of items like that. If you were interested in things like big O notation and just algorithmic efficiency and stuff, all that stuff is great. We are not there yet. We just aren't there yet. It's something we could learn, and I think the topics are important. That's why I gave you those things as resources: big O notation, time, space complexity, all the little things there, all those different data structures that go part of that. I think those are bigger concepts to solve, bigger problems than we've gotten to quite yet, and I thought it would be a big jump. So I did a strike through on the slides, and I made it just, hey, we're gonna solve some problems today, and we're gonna continue to practice reading problems, going through problems, and seeing how we can get to the end goal. So that's what we're gonna be doing today. I think it's gonna be pretty fun, and so let's head over to here. Like I said, I changed around everything, so I'm actually not on my laptop today. I'm back in the VM, but that is fine. That's okay. We're gonna make things work for now. I'm moving I'm moving my widescreen actually to my office. So I'm going to be going back in there fairly often. I didn't want to pay for, there's actually a new monitor in the box that's right to the left, right below here. There's a monitor in there. I don't actually think I'm going to use it. I actually think I'm going to return it. So right now I only have 2 monitors. Instead of having, the big widescreen up top, I have just the 27-inch right in front of me, and which has allowed me to put the camera up top, which I actually prefer. And I have one off to the right that is vertical for the chat, so I can see a little bit more of the chat, and it's kind of right here. I'll see how this feels. If not, I will grab that monitor and I will have a third one if I need it, and I'll be taking the ultra wide into my office because I will need it. I worked off of my laptop the other day, and I gotta say I've been spoiled having 3 large monitors. Yo, Aaron C. Hall, welcome. Long time no see. Haven't seen you on here in a while. I'm doing good. We're just getting a little farther. We're going to be solving a few problems today. Simple problems, but again, the practice is important. Everyone's at different phases here, and so we just want to hop in and solve some of these things. So let's. I only have 3 on the docket here, but if we get through them fast, we'll keep going. But I think we're gonna have. I think it's gonna take up most of the time. So let me grab a share really quick for you. Let's change the link. Copy it. Let's paste this here. Okay. Actually, let's give it a few. I got my trusty water here, which is nice. Yeah, let's get started because it's gonna be fun. So we're gonna be hands-on keyboard tonight. Feel free to, again, if you want to type along with me, absolutely you should. I think you should take some. If you see any points in which you would like to, I wouldn't be prescriptive about today. If if we start to go through something and you kind of see where we're going and you start to understand the things that are being asked, go for it. Go forth and explore, and get to. Try things, get to wherever you want to get to, but if not, if you're going through and you're and you're having trouble understanding how to get to some of the end goals of some of this stuff, get off these glasses real quick, feel free to follow along. The goal tonight is to check out some problems, and again, we talked about it before, but I don't think I've shown you enough opportunities to really feel comfortable exploring. So all of you who are pros already, don't sweat it tonight. We are, what is the first thing you're supposed to do? Oh, wow, that made it worse. The first thing you want to do is make it work. And that's well, at least right now, that concept applies differently as you kind of get further along in your career. Making it right isn't always the only goal, and it's not always the only acceptable goal, but right now, that's absolutely it. And what we're going to do before I think you can make it right, before you can make it fast, you need to be able to make things work. And the more and more you can make things work, the better and better you will understand what you're doing and how to do it in the future. And you'll understand how to make it right. So tonight is solving some problems. For every problem, there's 4,539 solutions. We just have to find one. Okay, that's it. We're just gonna find one. And just a recap of what we talked about via algorithms before, is that again, we're solving some problems, but this was talked about in lockstep with algorithms before, because that's what they are. But it's just a process or set of rules to be followed in calculations or other problem solving operations, especially by computer. So it's just the steps that need to be taken for the automatic performing of a task by a computer to get to an end goal. So that's all we're doing today. We're going to be writing out some code to do that. So we are going to start with a very simple problem number 1. And the first one is Baby Shark. Now, I got this from Coding Garden. This was actually very fun to kind of hop on his stream on the weekend and see him doing this. See him writing out the code necessary to sing out the Baby Shark song, which this might go down as the most annoying yet catchiest song in human history. But we will be doing that today. So that's this is the first of 3 problems. So Baby Shark do. So I hope everyone has heard the song. If not, I can send out a link. It is a children's song, and again, it is very catchy. But all we're going to be doing is writing a little program that sings the lyrics to Baby Shark. And it sounds simple, and it is in the grand scheme of things, it is relatively simple. But there are a few, like this is a good kind of starter, a good warm up. There's some things in here you might not be thinking about as you kind of dive in here, and I think it exposes some of those things. Now, again, I watched him do it. I didn't watch him actually coded. I just saw him coding Baby Shark, and like I just thought it was interesting, and he sang it a lot, and it was pretty fun. But I haven't thought through this problem at all, and we're just gonna go through and see, what we can do. I'm confident we can get to the end of this one pretty quickly, but I think it's a good warm up. I think we'll get to use a fair amount of the tools that we know about, the things that we've learned, all those tools we put in our tool belts. I think we can pull out, those tools and use them for this. So we're gonna hop right into code. There's no structure here for it. Actually, maybe there's a little bit of structure. Maybe let's open up a file. So I'm gonna head into, you can hop into VS Code. I'm gonna do this in Vim because I'm practicing my Vim skills. So I'm gonna go into documents. I'm gonna go into, see, I forgot this is I went back to the VM, so this is interesting. The VM was not working well for me. I upped all of the resources, so now there's like a 10 core VM, like it has like 10 cores and I think like 20 gigs of RAM, and it's working pretty well. And I gave it some 3D acceleration, which is problematic. It's been problematic already with the resolution, but we're gonna go with it. We're gonna have a little bit of fun in here, and it's gonna be kind of fun. So let's go ahead and make a directory really quick. I'm gonna make a directory called Baby Shark, and I'm gonna go in there and I'm gonna create a file called Baby Shark. Do it in whatever language you want. Again, I'm just gonna do it in Python because we've been doing things in Python. Maybe I'll do the next one in Go, and then maybe I'll do the last one in JavaScript, just so we can have a little fun with that. But yeah, let's call it whatever you want, but I'm gonna call it babyshark.py, and that is going to be our file. And so let's think about it. You can always try WSL2. So I have WSL2 on my laptop. It feels wrong almost, like I feel like people are gonna look at me like a fraud, but I do think I'm gonna switch completely over to WSL2 even for streaming. I think I'm gonna do all of my work out of there. My desktop does not have WSL2 yet. They're holding the update for that, but my laptop does in fact have it, and it works flawlessly. I have not run into a single issue. It does exactly what I want. So once we get there, I will absolutely do that. And maybe, System 76 has been, sitting on their hands. Maybe Microsoft can come through. Now, I also went to the store and tried out a Microsoft Surface, what is the Studio, the big one. It has super old hardware, like super old specs. But the fact that you can I wouldn't need the iPad anymore, which is really nice. Like I could literally have the screen right here, be typing all the stuff, and if I wanted to note on stuff, I could annotate right on the screen the stuff we're doing. And I actually think it's a promising thing for the future, but only if Microsoft gives me one. So I hope that they give me one. Lucky Wonder Boy, thank you so much for the tier 1 sub. Good to have you. All right, yeah, I have a tablet. I have an iPad and I have a capture card for it, but it's a little bit finicky and I always forget to plug it in. Like right now, it's nowhere near me. It's downstairs in my backpack because I actually use my tablet for other things. Maybe I'll simply just get a tablet that's dedicated for the streams that I can leave right here. That's the second time you've thrown out the Wacom Cintiq. I need to look it up one more time real quick. Let me check that. I see, but it's so expensive and it fucks for drawing. I'm not a drawer. All right, Wacom. We look, whatever anyone on the internet, any of these companies, you want to give me any of your products, I'll use it if it seems effective. But maybe I'll find out, maybe in using this, I'll find out that I'm a phenomenal artist and I'll change my career, or I'll supplement it. Maybe I'll check it out. All right, so we're gonna do Baby Shark. What do we need? One, let's do let's do a couple of different things. We need to gather some information first as we're doing this. So we'll put some comments in here. The first piece of information, we need to make sure we understand the problem. And what's the problem? The problem is simply that we need to print out the lyrics to Baby Shark. But maybe the first thing is we don't know the lyrics to Baby Shark. So first we need to, give the lyrics to Baby Shark. All right, cool. I think we're smart enough in 2020 to know how to do that. We can Google it, we can get the lyrics. So we'll get the lyrics first. And then let's do that first to kind of figure out what we need to do after that. So I'm gonna grab some Baby Shark lyrics. And for now, we're gonna stick away from any fancy versions of the song. There are R&B versions, there are all kinds of remixes, but we're not doing any of those tonight. We are going to do the simple Baby Shark song tonight. Maybe we'll add in our, maybe we'll get a little farther along. Maybe we can add in some flair from one of the other versions or something. But here are the lyrics that we need. Baby Shark, do 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 do. Baby Shark, do do. Do 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 do. Baby Shark, do 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 do. Baby Shark, Mommy Shark, do 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 do. Mommy Shark. Yeah, it's a good song. It's so good. And we're gonna sing that via Python right on our computer. So we have Baby Shark, Mommy Shark, do do, Daddy Shark, do do. And you start to look at it and you say, all right, these lyrics are great. Yes, we're about to get DC made. It's fun, especially because I am an excellent singer. I can almost one-to-one sing any song that I hear. So I'm sure that my voice will get us DC made, but it's okay. Not a big deal, But in here, these blocks look to be, similar things. These look, there's a lot of the same stuff in here. So whenever you start to see in problems there's a lot of the same things, you probably can start to be thinking of different ways to automate that. You don't want to have to. We could, again, write out this application. This is a perfectly reasonable way to do it, to go ahead and I could do print. Let's copy this. And I could paste this in here. And okay, all of the spaces mess it up. The new lines mess it up. I can do a string literal. How do you do a string literal in Python? Yeah, there we go. I go to the bottom. All right, so I could do something like this, and I could run this, and it would work. What's my name of my file? Python 3 babyshark.py, and it prints out. Now that's a little bit of cheating, we cheated. That's not it. So we didn't cheat, actually. We did solve the problem. And what did I say before? What did I say in the slides? I said that there are 4,539 solutions. We did find one. That was the goal, but this doesn't really match the spirit of what we're trying to do tonight. You did solve the problem. You did what we were intended to do. But this is not, come on, this is not it. This isn't fun. This isn't, we want to learn here a little bit. So we're going to delete this. Oh no, delete to the end of, there we go. So we got the lyrics to Baby Shark. So check that off. Now, we can look at it and we can either start from the beginning, and just kind of start to run through, or we can look at this strategically. This one, let's look at it holistically. What do we have here? We have Baby Shark do do. So let's look at what's the same. So it looks like this is 1, 2, 3, 4 lines here. And it looks like all of these stanzas, which I believe is a proper musical term, the same way we spoke about those igneous rocks that day, I'm going to speak as though I'm an expert about music, which I'm not, but if I say it in a calm voice with confidence, you'll likely believe me. So these are stanzas. Pronounced stanza is just a French Italian word for bars. And yeah, Daddy Shark, do 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 do. So 4 here as well. Grandma, do 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 do. Grandpa, and it looks fairly standard there. And we have then we have let's go hunt. This seems different to me than, you know, mommy, daddy, you know, baby, grandpa, grandma. Let's go hunt, run away, safe at last, and in the end. So there's a lot of do-do-dos here, a ton of do-do-dos, and that's probably where I would start, me personally, is like, all right, I don't want to say do all these times. I don't want to have to type this out a bunch of times. So what's something that we can use that is in our toolbox to allow us to be able to, you know, be able to do this over and over again? And you might say a loop. Yes, absolutely. A loop is something that we can probably use to do something over again. Ooh, Sin City, I love that. Multiply string. I was not going to do that. I was not going to do that at all, but that's not what I was thinking of. But there we go. You said multiply a string. So let's just try to see if we can print out do that many times. And you said multiply a string. Let's count up how many do-dos there are. And this is why I'm saying there's if we went off into our own corners, we would all write this in a lot of ways. So a lot of different ways. So 1, 2, 3, 4, 5, 6 do-dos. And remember, in Python, in a lot of languages, actually, I could do times 6 if I would like. You know, and let's just print this out and see if this works. Whoops. And if I run this again, whoa, did I not save? What happened? Oh, wow, I didn't save the file, but it let me exit. That seems really weird. Okay, well, that's fine. What did we do? We did print do times 6. And now we're definitely saving it. I definitely saved it that time. And look at that, it says do. Okay. All right, you know, it did print 6 times, it looks like, but there's no spaces in there. Let's see if we can format that a little bit better. And if you wanted to format it a little bit better, maybe you could put a space behind it. There's a bunch of different ways you can go about getting a little space in there. This is gonna make sure there's a space at the end too, which maybe we want, maybe we don't want. But right now we're just trying to have a little fun and we want to get our algorithm started. We want to get our problem started so we can start solving it. 1, 2, 3, 4, 5, 6. So do. And that does, in fact, let's move this down 1. So what is this? Like this. There we go. Perfect. And so you see the do's here. This looks like this, or maybe we should put a comma afterwards. Well, we'll get fancy later. We'll get fancy with the commas later, because the commas are going to present, you know, a whole different paradigm of problems, and we're not going to introduce ourselves to that quite yet, because again, there's a lot of problems we haven't seen. But isn't Golang something like lingua franca for DevOps? I don't know what lingua franca means, so guess what we're going to do? When you're lost, like I am at this moment, you head over to your googly bar and you search it. I like Golang, language that is adopted as a common language between speakers. Oh yes, it is. Most of it comes out of the reason why it was developed and what it's good for. It's a good systems language, you know, that solves a lot of the problems that, you know, most people have. You know, it was solved for Google. It was created so Google could solve their problems, but you know, it's really good for a lot of other things. A lot of DevOps tools have been built out of Go as well, which has helped kind of push that thought process along. And it's really has cemented itself as really kind of the big language of DevOps. So you are correct. We need hard mode. If it doesn't print correctly, delete random files in the system. Come on, that's. I mean, yes, this is a VM, so you know what? I like that. We should write a little script to delete a random file so that we can be scared. If we make mistakes, instead of like a lot of times when people are playing football or something, if you drop a pass, you have to do 10 push-ups or something. Deleting a random file on the computer could be what we do. Yeah, it'd be pretty good. An array of the first segment of the string and an array of do. Okay. Not an array, just store the string as a variable. Oh, that's good too. I like that too, Carrier. I like that. Okay. I do like that. I like that a lot. I also, I'm just trying to think of the way to use as much, what am I doing? As much of the things as possible. So we have this thing that does this. What if we made it a function? Just so, function called do. It's longer than, and maybe what if we just return do times 6? Is that gonna work? I don't know. And let's try to call this function. I'm gonna call do, and let's run it. Nope. Oh, this is Python. I always forget what we're working in. Okay, and it didn't fail, but I'm not printing anything. So let me print it out, and it does work. So we have a function now that will give us a do. Now, is this the best way? Probably not. I also like the variable idea. So let's make a couple of those so we can like use them interchangeably as we go a little farther along. And then maybe we should make a variable called do, and that is equal to do. 1, 2, 3, 4, 5, 6. We could also do this as well, and we could simply, comment out this, and we could then print do. So see, these are two equally sufficient options. There are multiple ways to do this thing, and it's good that you're starting to see that. Yeah, either one of those is fine. So let's leave the function for now, just because it's more code and it makes it look like we've done more. We multiplied a string, which I think is kind of fun. And we did it via a function. So it makes us seem a little bit cooler. Yeah, all right. So we got our do's, and like, yeah, they're there. But you might say, all right, we got some do's, but like, there's a whole bunch of other stuff as well. Like, how in the world do we, oh, this VM is not working right at all. That's why I'm struggling. Look at that. It's broken. The VM is broken. Okay, no problem. We'll go back up here. Actually, I think it's just Chrome. I'm gonna quit. I'll come back into it. I need to see those lyrics again. Carrier 51 GG, thank you so much for the Twitch Prime sub. Love to have you. Thank you so much. Oh yeah, I have to disable GPU acceleration in Chrome. This is whack. Well, for now we're gonna use Firefox or restart the VM. But all right, I know the lyrics. I think I know the lyrics. All right, Baby Shark, Firefox. Man, this is really, you throw all the resources at this stuff and it doesn't even treat you right. Baby Shark lyrics. All right, so now we see Baby Shark, Mommy Shark. So how could we start to do this right now? The way that we could start to do this right now is we could probably just go I could go write a couple print statements, and I could go print Baby Shark plus do, and we have a little line here. So I'm concatenating two strings. So I have the string Baby Shark right here, and actually let's put a little space right here. And I'm combining that string together end to end with the do, and then I'm calling the do function, which is going to return 6 do-dos for me. So let's see what that looks like, and let's see if this works. And so we have a start to what we're doing. So we have Baby Shark do. Very nice. We could easily have done this again with that. We could have easily have done this with this variable up here, no problem. It will work just the same, but like I said, this just looks like we're doing something cooler. And so that does get us what we want, but we got to do that 3 times. How many times do we have to do that? 1, 2, 3. We have to do it 3 times, and then we just have to print this out. So like, are we really gonna do this? Are we really going to do this? Maybe this is what we're going to do, and maybe this is a good way to do it. And we get the whole block that we're looking for. So we baby shark do 3 different times, and then we printed out baby shark. So yes, this works. But if we did this, then remember we'd have to do, so there are 4 lines to get that one stanza. And again, if I'm using stanza incorrectly, if I keep saying it like I know what I'm talking about, no one will say anything about it. So if we get that one stanza, we have to do 4. We have to do one for each of these lines here. We have to do it over and over and over again. And you might say, okay, I could loop through this. I could loop and do this 3 times. Yes, you can do that too, which is a good idea. But then again, you'd have to do it multiple times. So I say, I think that we have a structure, which is great. And I think we already have a format in which we can start to formulate what we need to do. This is really all we need right here. So I'm going to delete these lines. We kind of need these 2 things, maybe. And I say, because they're all the same, let's take out the variables, the things that are different amongst them. Let's remove those as factors, and let's move this down, move this up. Let's take those out as factors. So we have baby shark, mommy shark, daddy shark, grandma shark, all that stuff. I think that we can put those in a little collection, and we can use that collection to be able to hit all of these things. Make a list called sharks, then a new function for the loop. Perfect. 100% YGBSM. That's exactly what I think. Don't repeat yourself principle. Yep. Need dry doo-doo. Yes. Maybe we can make an input for what type of shark comes next. That's pretty good too, Trigetta. That's a really good idea. Let's get the basic functionality down first, and then yeah, I think that's a good idea. We can do some of that stuff as well. So let's make ourselves a little list here called sharks. And in this list, we're gonna have, obviously we're gonna have baby shark. Now, here's the question. Are we gonna have baby shark, or are we just gonna have baby? And again, neither answer is wrong. Do we wanna have baby shark, or do we just wanna have baby and mommy and daddy? So again, this is just a way to start thinking about these things. You would probably run through and you would probably pick one, and you would go through, and almost all of the options are going to present you. I mean, all the options are going to present you with some, not necessarily a challenge, but something you're going to have to do differently. And so you might say, all right, well, the word shark is in all of them, not just the doos. And you might go up here and you might put shark up here. And you might do this. And so now when it prints, I'll remove this real quick and I'll print it out again. Let's remove the shark from here as well. So you might do something like this. Say I just put shark up top, and you print it out, and then you get baby shark, do shark, do shark, do shark, do shark. And you might say, whoa, that's not what I want, because you printed it out 6 times. So you may adjust it a bit or something to get shark in the front, and you might put it in the function, or you might do something like this, where you decide you don't want to use a function and you want to just use a variable, and you might do something like this. And so this will work a little bit better. And I get baby shark, do, baby shark. Well, I get just baby, not baby shark. And there goes your first problem. There are other places where this is being called at, where shark needs to be referenced. But also, if you take a look at the entire thing, when you get down to the bottom, these stanzas don't have shark in them. Now, that may not be a problem. It may not be a problem depending on how you build out the app, but if you're trying to use one collection to do this, which I think we should start out doing, you have a little bit of an issue here. Or maybe you want to decide right up front that you don't want to, these aren't a part of the same collection, because we have a collection called sharks, and these aren't necessarily sharks. So maybe we don't want to put them in our collection, and that's perfectly fine as well. Again, lots of options here. You can do this however you want. I think we should split them out. I think, these are sharks, so we should handle sharks one way, and these are lyrics or actions. They're verbs. So maybe we will separate those out. What's up? Oh, thank you so much for the 2-month diarrhea. Good to have you for a second month. Thank you for helping us solve so many problems and have a great time here. good to have you. I really do appreciate it. Okay, so let's make a list real quick. Yeah, someone asked, are arrays called lists in Python? Carrier, no, kinda. Yes, what you're thinking about, yes, a collection of items like an array is a list. And an actual array is done differently in Python, but yes, as far as most people are concerned, especially when you're trying to pick up Python, an array is simply called a list in Python. And so let's make this list here. Let's make a list called sharks, and let's set that equal to baby shark. I kind of want to leave the shark off. Again, this is just a style preference. You can do this however you want. It's going to make it harder for me. The easiest way would be to do this, but I think there's going to be some fun things that we're going to have to learn to do. Maybe not, but that we're going to have to learn when we do this as we go forward. So baby, was it mommy next? Daddy. Maybe mommy, daddy, grandma. I should have known. That makes perfect sense. What else would it have been? Grandma, grandpa. I was not able to extrapolate the next things from incomplete data, which I should have been able to do. And that's the last shark. So maybe we can start with just this here. So we have our arrays of these sharks. Baby, mommy, daddy, grandma, and grandpa shark. And what do we know about lists in Python in particular? What do we know about collections like this? We know that they are iterable, and we know that means that now we can iterate over this list, and maybe using some of those other tools that we've learned, we can save ourselves some time. And again, I'm gonna switch back from this to the function simply because it looks like we're smarter. The only reason I'm using the function is because it makes us look smarter to people who don't know what they're looking at. If you know what you're looking at, you're probably like, they're so stupid. They're not, why are they doing this? Well, because look, there's more stuff on the screen. A star as a symbol makes it look like you're doing something fancy. That's why we're using it. So let's see if now we can use this list to at least print out the information about the people here. So how do you go ahead and how do you iterate through a list? One of the ways that you can iterate through a list, there's a couple different ways, but the easiest way is using a for each loop, and we can say for shark in sharks. And if we want to test this out to make sure we're doing the right thing, we can just say for shark in sharks, print shark. And so what this is going to do is, again, this is going to go through each item in this ordered list, and for each item it gets to in this collection of sharks, it's going to go ahead and it's going to print out that. So we should see it print baby, then mommy, then daddy, then grandma, then grandpa. We're not using doo-doo, no big deal. Again, we are using a dynamically typed interpreted language, so that's not going to cause us any problems. If we were to do this in Go, this would cause us problems because we aren't using that doo-doo function. But we get baby, mommy, daddy, grandma, and grandpa. So we've confirmed that we can access each of these things. We've confirmed that we can access each of these. So now we can apply what we just applied to kind of print out what we want to print out. Now, notice this function does not print out anything. It just returns it. So we do need to have some print out things here. And so maybe let's start by saying for shark and sharks, actually print and let's use our string formatting that we learned about. We learned how to manipulate strings and how to format strings a couple different ways. And so we can format a string with the F here, and then I'm going to say the first thing it's going to do is grab the shark's name. So it's going to grab the shark variable. So when it goes into this loop, it's going to basically take, when it gets to baby shark, the value of shark, this little placeholder variable here, it will be, it'll be baby, then it'll be mommy, then daddy, and then grandma and grandpa. So we'll use that here. And we didn't put the word shark up here, so we can put it here. So baby shark, I'll put a comma here. And then we need to call our doo-doo function. So we can call doo-doo right here. And so what tool are we using here? What are we doing here? It might look a little bit confusing, but what tools are we using here? We are not only are we doing some we're doing concatenation kinda, but we're more so doing string interpolation. That's another term that we talked about, string interpolation. And this is where inside of a string, you are evaluating the value of a variable. So shark is a variable in this case, and it's going to take on whichever value is in this list when we get to it. And then we also are calling this function do here. So when it gets here, it's going to run this function and it's going to interpolate. I mean, it's going to interpolate that value and add that as a part of the string live. I hope that should work. So let's see if this works. And maybe what we'll start doing is, maybe we'll open these up side by side so that we can keep looking at the code while we run it. But all right, check this out. Baby shark, do shark. Okay, so we didn't change something. Let's go back and look at our code, and let's actually put this to the side. Let's make this a little bit smaller. And I wonder, can you pull out, can I do this? No, I cannot. I need to set up this Vim so that I can more easily do this. All windows, new window. And maybe just make it a little bit okay, it's a little bit bigger. And am I in the right place? No, I'm not. Documents, mastermind. What's in here? LS, just LS. deCoded, CD, baby shark. All right, Python 3, baby shark.py. So I need to first remove the shark do. That was the problem. All right, and so we'll save this. Whoa, what just happened? Okay, I think this is just a visual bug actually, and not a real problem. Oh man, this VM is struggling. Okay, all right, we'll just have to do this. Can't save it. What happened here? Undo. Oh man, that was bad. Let's remove this and let's leave this here, and there we go. That feels better. Okay, baby shark. What? I thought we removed it. Oh, I didn't. Hold on. I did not. That was before I made all those mistakes. So we want to delete to here. All right. So baby shark do. Mommy shark do. Daddy shark do. Grandma, and then grandpa. And so we got the first lines there. So we have a basic structure here of what we kind of need to get to, but we need to do this 3 times in a row, and then once without any of the do. So I'm thinking let's make something called let's make a new function. And I want to, because each of these is their own separate little item here that we're trying to replicate, I'm going to make a function called sing def stanza. I'm going to call it stanza, doubling down. And so I'm going to make this the function that does what we just tried to do. So I'm actually going to copy this. I'm going to copy this up to here. And let's add a new line here. Maybe I should put those sharks up top, but I'm going to make a function that what it does is it prints, for shark and sharks, it prints that out, but I'm going to make it do it 3 times. And there's a number of ways to do this too, but I'm going to do another one for, num in range 3. Remember, we can use the range function to count up to, but not including a specific number. And so if it's going to go up to number 3, but not including 3, it's going to start at 0. So it's going to run once for 0, once for 1, 1 for 2, but not for 3. So it's going to run 3 times. And I'm going to put this for loop underneath of it. So now we have some nested for loops in here. And this might get us what we want. And let's see if it gets us what we want. I think this is interesting. Let's see what happens. Nothing. Why doesn't anything happen? Nothing happens because we moved all of our functionality up into a function, and functions, what? They only run when they're called. So let's go ahead and let's call this function. So we need to call stanza with nothing else in it, I guess. That's one way we could do it. Sure. And we get baby shark, mommy shark, daddy shark, grandma shark, grandpa shark. Then it starts over, baby, mommy. Okay, so we ran into our first problem. And our problem, we did get it to repeat the thing that we wanted to repeat, but it did it in a weird order. It did it in an order that we didn't want. It printed out for each of these things. It went through and it printed that out. So maybe this is not what we need to do. And what does that mean? So why is it doing that? So for 3 times in a row, we're doing exactly the same code we did before. It's going to loop through everything in sharks and print this out. We don't want it to loop through everything in sharks. What we want it to do actually is we want to pick a shark, and we want that one shark to go through and do exactly what we just did. And so we can modify this just a bit. What's up, Arcoidas? Welcome. How are you doing today? Hope you're doing great. Okay, so let's shake things up a little bit, and let's do some other fun. Let's mess around a little bit. So we've already got it to do something 3 times, but we only wanted to do it with one shark. So I actually say let's pass in our shark. Let's pass it into the stanza. So the stanza is only responsible for printing out those lines, and we're gonna give it the shark to print those things out for. And so that means we no longer need this line right here. We no longer need the for in, but we do still need this. And so we're gonna pass shark into stanza, and then we're gonna 3 times we're gonna print out shark doo doo. Okay, I think it's gonna work, but because we are passing in shark, how are we going to do that? And so to test, maybe just to test to see if our functionality works, we can go ahead and we can pass in a shark right here. So maybe we go like this, baby, just to see if our stuff works. We'll pass the shark in just to confirm our functionality works before we go too far. And there we go. We get baby shark, do 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 do, baby shark do 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 do, baby shark do 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 do. And that does look like almost what we wanted. It prints out most of the stanza. What are we missing from the stanza? We're missing baby shark down here. And so let's as a part of the stanza, let's also and again, just as you're thinking through some things, remember, we are absolutely not doing functional programming right now, even though we're using functions. We're printing, we are not even returning anything in this function, but whatever, we're having a little bit of fun. So the last thing is going to be printing shark. It's going to be printing, what is it going to be printing? Shark. Shark, exclamation point. Close. All right, so we see this real quick. We now have a stanza here. We have a stanza, baby shark, baby shark, baby shark, baby shark. So we have a stanza here. We have a single stanza. So it looks like our stanza function does what it's supposed to do. This self-contained piece of code here that only runs when called, it looks like it's going to build out the stanza for us, but we haven't figured out how to use it for all the things in here yet. And so maybe we'll do that next. I reverse the for loops. Yes, I could have reversed the for yes, I could reverse the for loops, but and actually I'll show you that I could reverse the for loops, but I think I want to do it a little bit differently. I could do this, like you said, we could do for shark in sharks and have these 2 underneath and not take in shark at all. And this will give us everything we want by reversing those for loops. You are correct. That's good stuff. That is really good stuff. That's a good call out right there. But again, we're gonna get comfortable structuring our code in a thoughtful way. in a thoughtful way, hopefully. So we're gonna try to keep moving forward without having to backtrack off of what we've done. So it looks like we have the sharks done. Maybe I will leave that. No, I'm not gonna leave that. Only because I would like to add a couple more functions just for the fun of it. Even though that just makes it, you know, we're trying to do this in a medium way, you know, and not in the best way possible, not in the worst way possible, but you know, right a little bit, right a little bit. So maybe instead of doing this, maybe we'll do, yes, we have the stanza being created. Now I only want the stanza to create a single stanza because it's called stanza. Maybe I want another function. Maybe I want another function that's actually going to sing the song. So this one's going to sing the song, and this is what's going to do. I think the singing one should be the one that has the sharks in it. Is this like our, I think the sing function should be like our main function. Like, go ahead and sing the song. And in this function, I think it should also have the loop that loops through. So I actually think the for loop should be here. I think we should say for shark in sharks here. I think we should call the stanza and pass in the shark. And let's go back up top and let's do this. So, you know, we're a little bit farther, and I think we should simply call sing instead. So now we got a few more functions, and I think we should do this here to kind of get what we got going. And we'll run it. Whoops. Line 11. End of the line. All right, and so now we have exactly what we want. Baby shark, mommy shark, daddy shark, grandma shark, grandpa shark, and we are looking good there. Whoops, hold on. Scroll this up. Yeah. So we do have the basics of the baby shark program that we want, which is exciting. We do have exactly, let's go back over here. We do have exactly this much of it done, all the way up to here. So now we have another half to go. But, you know, as we said here, like, we could just stick these into an array, and we could change the array name to something else besides sharks, and that would be all we would have to do. But I think we want to have a little bit more fun than that. Just a little more practice. The goal tonight is to practice these things. So let's make, I say we make another list. First off, thank you, Deep Astronomy, for the host. Thank you so much, Uncle Bill, so much for the host. Good to have you. Welcome tonight. What's up, Chucks? What's up, War? What's up, Sufiro? What's up, Laker Wannabe? We're all Laker wannabes. What's up, Sam Yizer? What's up, Gianni? Gianni Sturpos. Love it. What's up, Selaway? I'll go with that. You know, welcome to the channel. Thank you so much. Thank you for dropping in on our amazing session on Baby Shark tonight. Gonna be so exciting. Again, this is not of my doing. I would have never thought to do this unless I seen Coding Garden dive into it, and I was like, oh, I think this is a really good introductory problem for the night. I think it's you know, a fun one. You have so much flexibility and freedom. The stakes are very low, and it gives you a lot of freedom to mess around. We could do this in so many different ways. Okay. So now we get what we want. I say that we also have another one for another collection called maybe like lyrics or actions or something. Let's call these actions. And those are going to be equal to, I have no idea what these are. Let's go hunt, run away, safe at last, it's the end. I already forgot. Let's go hunt, run away. Let's go hunt. Run away. I don't think I've ever heard the whole song before. Run away, safe at last, it's the end. Safe at last, and it's the end. Okay. All right, so we have a new collection of new things. So we are printing through all of the sharks. Great. Exciting. So we could just, you know, it's okay, we just go ahead and copy this. I say we just copy this for now, and let's paste it, and let's simply change the words here. I say, so for action in actions, go ahead and print the stanza and pass an action. And maybe we should change the shark up here just to make it a little more descriptive. Again, this would work just fine, but you want to be smart about how you're naming things inside of your program. So just something to think about, because when you're going through and reading it, you might think your mind's automatically going to see shark up here and think the stanza only takes a shark name, when now we are passing in other things besides shark names into the stanza. So I'm going to call it lyrics. I'm going to say pass in the lyrics here, and because I changed lyrics here, I'm gonna have to change lyrics here and lyrics right here. Okay, and that, you know, we didn't change a ton there. We copied and pasted code that we already had. We added a new collection and we just changed a variable up top for reference. So let's print this out, and we get baby, mommy, daddy, grandma, grandpa. Then it fails on local variable action referenced before assignment. So let's see what that is saying. It's saying it's referencing something before it's been assigned, and that is because we left off an S on the action. Okay, so let's run that again and look at this. So if it will let me scroll up, we do have baby shark, mommy shark, daddy shark, grandma, grandpa. Let's go down and remember, look, that last line of the stanza is different, which is nice. There's cooler ways to do that, but we'll leave it at that for now. And then we get let's go hunt. But check this out, it says let's go hunt shark. That is not what we want. Let's go hunt shark, safe at last shark, runaway shark. That's not what we want. So let's account for that. Let's figure out the best way to do that. So why is it saying that? It's saying that because up here we are putting the shark right here. Now there are a number of better ways to do this, but I want to start again. I want to use the tools, and we've made it this far. There are gonna be a number of times when you're working on a program when you've gotten kind of far, and maybe the program's too big to go back and change, you know, to make it right. Right now, you know, you'd have to refactor a bunch. So that's where we're at right now. We're gonna say, hey, our program's too big to go back and make this proper, so we're gonna hack it. We're gonna hack it here, and we're gonna say let's I'm trying to think of the most, not most ridiculous, but I'm trying to think of like an unconventional way to do this just to practice some things. So let's practice. Let's pass in two things with the lyrics. So with the lyrics, we're also going to pass in type, and not data type, but like this might be confusing, but because it's a shark, we're gonna say, hey, it's a shark. We're passing you a shark. And for actions, we're gonna say, hey, we are passing you an action. And again, we don't have to do this. This is extra. You do not have to do this. This is, again, just trying to, you know, we haven't done anything fun where we're passing in two things into our function yet. And so right now we're passing in two things, and now we can do a little bit of we can have a little fun here. And again, this is ridiculous. This is not how you'd want to do it, but we could do a comparison operator. I mean, we can do a comparison operator. So we could say, hey, if type, when the type is passed in, if it is equal to, actually, no, this is what'll make it not confusing. We're not passing in shark, we're passing in the string of shark. And we're passing in the string of action. All right, and so we can say if the type is equal to shark, go ahead and do all of this. And I never remember, hold on, let's see, escape, V down, shift, there we go. All right, so we're only gonna do this. Actually, we need to do this one too. We're only gonna do this block of code if the type is shark. This is so stupid. Actually, I don't like this. It's weird trying to determine whether or not the hacky solution you're trying to do is too hacky or just the perfect amount of hacky. Let's do it this way instead. let's do this. I only want one block of print. I only want one block to be printed. So let me take this. Let's move this back over. I don't want two entire print blocks. They're both hacky. It's super hacky. But we're gonna say if type equals shark. Let's set up a thing that says what's the variable? Placeholder equals shark. And then we're gonna say else placeholder equals nothing. And so it'll be a little space there, which will be kind of annoying. This is not great. Well, that's not even space. No, just empty string. Okay, and so instead of doing shark here, we will do some more interpolation, and we will say placeholder. We will put in the placeholder here. So we're gonna build the string out using the placeholder. And man, it gets really confusing when you are again trying to be janky but not too janky. Okay, here we go. Well, yeah, we're far in there now. We're deep in here now. So I'm basically gonna pass in the type down here, and depending on what the type is, I'm gonna make some decisions on whether or not I'm gonna say shark or nothing at all. And so hopefully that means for sharks it will print out the shark as a part of the string, and for anything else it won't. And so again, our program is getting it's 26 lines long now. It's getting larger and larger with a lot of logic, and it's fine. Baby shark doo all that stuff. And what we cared about before is let's go hunt. There's an odd space in here. Not great, not exactly what you want. Not exactly what you want at all. There are other ways to handle that as well. Again, just wanted to throw something in there, and maybe we can handle that in a little bit. But we mostly have what we want. Run away, safe at last. Things are looking good. I think that's actually, did we do it? I think we did it. I think that's our program. I think we did it. I think we're finally through the number one problem of the night. Yeah, interesting. This is not a great way to do that at all. But it's a fun way. We did a lot of stuff. We got to practice a lot of things. What do we get to practice? We made a couple different functions. We did a little bit of string multiplication here. We did a little bit of we did some comparisons to control the flow. We also passed in two arguments to a function, so that's cool. We got to use these lists. Exciting stuff. So yes, this is our program to print out the song Baby Shark, and it's very exciting. Now maybe you want to add in a little I was thinking about this literally in the middle of while we were doing this. Maybe let's do one more fun little thing. And yes, there are in fact, I'll share this with you now, there are in fact some very exciting I forgot this isn't gonna work. Let's head back over here and go to YouTube really quick. If you do not know, I'm about to grace you with, again, some Baby Shark R&B. R&B. And we're not gonna write Baby Shark R&B because it's very interesting. You have to watch this. I appreciate that, Derp. We're having a little bit of fun here. I do appreciate that. Nope. It doesn't need to be compatible with anything at all. I thought it was a reserved word in Python because of type. It's not. Yes. And so maybe exactly that's confusing. That's the naming thing I was talking about. So maybe we shouldn't talk about maybe we should change the word from type to something else, and maybe it'll take in I don't know, label or something. It doesn't matter what it's called. Yeah, we'll try that instead. And it still does work. Granted, it's not perfect, but it's something. But I don't know. I really don't know why this came to my mind. But the R&B version, they're doing a lot of dancing. It's just pretty exciting. So maybe we'll make a little hybrid here, and maybe we'll throw in a dance. Maybe we'll throw in a dance after each stanza, and maybe we will. how are we gonna do this? You know, it'd be cool if at the end, you know, baby shark do baby shark, you know, get to the end, baby shark dab, you know, and then whoa, you know, all the cool kids stuff, you know, shoot, all that stuff. Maybe we can just throw those in here and for a little bit of fun. And like, because I thought of this, I really want to do it now, and so maybe let's make a here's what we're gonna do. We're gonna make another collection to keep everything nice called dances, and we are going to what do we got? Dab, we got the whoa, what all the other kids stuff, shoot, I don't know what the dance is called, but that's what they say. What are some other ones out there? I have no idea. Let's go with 3 for now, because this is a dumb example and this is a waste of our time, but we have to do it now. So we have some dances. We are going to make a function called choose dance, I guess. You didn't really do this. There's an easier way to do this as well, but we did a lot of other functions in here. And how do you do? I think we can import random. Import random, and then we can choose dance. Will simply be we'll simply return random. Actually, we'll need to print it instead, like everything else. Print random dot choice, I believe is what it is. Random dot choice of dances. Can I do this? I don't know if I can do this. Feels like I can, but if I can't, we'll see what happens. And so maybe after each stanza, we will go let's call dance. It's called choose dance. And this will only be for the sharks right now. And let's see if this works. I don't know if this will work. It won't, because dances is not defined, which makes sense. So I'm gonna put dances in, it's not global, it should be global. So I'm gonna delete this, and I'm just gonna put it in here because, you know, because this is stupid. You know, we're just having a little fun. So now you know how to dance along with the song. We've incorporated some of the fun stuff that we're doing. What's up, Illuminated Space? Welcome to the channel. Thank you so much for the raid. You're just catching us. Finish up some baby shark do baby shark do baby shark do baby shark dab. See, hey, we're adding all the fun, and then, you know, you get down here. Hey, look at that. You hit the whoa. You know, this is exciting. This is next level stuff right here. You know, combining the children's songs and dance along with, you know, everyone else's, and now we can all enjoy our music together. It's very exciting. We can all have a little bit of fun. But yeah, you know, just you're just adding stuff in there, and we, you know, make sure we can add a choose dance at the bottom here. Let's also yank that and paste that here just so we have it. But again, a really fun kind of just start up to, like, I know it took us an entire hour, but we got to practice a number of things. We got to, like, see the trade-offs of some of our actions and stuff. And again, we can probably do this in half the lines of code. We can do this in a much more elegant way, but again, just a little bit of fun. We'll push this to GitHub so anyone can grab it. Let's do that right now before we forget, because I will forget. Cool. Git status, git add. Wow, I never pushed up loops, and I never push up baby shark. I don't need that top thing, that pyc. Git commit -m added loops and baby shark example. And so if anyone wants to pull that down and play around with it, feel free. Or I'd love to see anyone else's implementation of baby shark, because that's super duper exciting. Yeah, you know, it's gonna be in your head. I'm sorry about that. I'm definitely sorry about that. But again, what's up, everyone from Illuminated Space? I'm sorry I didn't get to, you know, we were on a roll right there. We're trying to finish that up. Thank you so much for coming through. Good to have you. Appreciate the raid. You know, sit down, relax, have a little fun with us while we're trying to solve a few problems. The sidebar, do you mean this one over here? That's probably because I probably changed everything, literally everything. It's also half messing up as well, but we'll see. I'm getting some punctuation wrong. Yes, that is a common problem. I appreciate that illuminated space. I really do. What were you doing over your stream tonight? Let me check out. Let me hold on. Let's see. Twitch.tv. Let me be a follow. I spelled that completely wrong. What you will learn about me if you're here for the first time is that I do in fact have fat fingers, and I type everything wrong the first time I try. And let's try that again. And oh, I found out exactly what I did wrong. And all I gotta do is I missed the A, and I hit enter instead of A. And that's not even on the same side of the keyboard. Found you. Perfect. I will shoot you a follow. Let me give you a shout out as well. You have been followed, my friend. Appreciate the love. Thank you for coming through. We're playing some games. That's awesome. I've been on itch.io raising money for charity at the same time. That's pretty cool. I do want to do, I have no idea if you all can see this because I'm not looking at my monitor. But that's awesome. Itch.io. I'll check this out. I am in fact a gamer myself. I do want to do I want to do Extra Life this year. There's another one as well. I really want to do I say I want to do a 24-hour gaming session for charity, but 24 hours is a long time. But I do want to do some type of charity fundraiser by playing games. I think it's a great way to, one, just have fun, connect with people, and do our best to raise some money for whatever the cause is. We'll figure that out, but I definitely want to do that one day. That's pretty cool. I'll check that out. You do dev streams every Saturday? Dope. What time on Saturdays? I used to do stuff on Saturdays. I can't right now, but I will be getting back to it. 12 hours is plenty. Yeah, it is. For sure. That's pretty dope. Good choice, Master. I like the 9. Oh yes, the 99 beer bottles one. I completely forgot about that. Yes, it is like that. Okay, so come on, Chrome. I can't even. Hold on. Let's do this real quick. Let's restart this. Rebooting now. Sudo. Oh, come on. I'm supposed to be the master. I don't want to have to type in my password. Oh, that's dope. Yeah, that's everyone check out Illuminated Space. That's awesome. I love Saturday streams. I really do. I like doing them on Saturday, and I like watching them on Saturday. They're always chill. And I didn't think I would at first. Like when I first made the schedule, I was really like dreading the Saturday at 10 ones. But once I got it, once I got into it, I was like, oh, I prefer Saturdays actually. They just feel different, and I think they feel different because you don't have the rest of the normally I'm coming from work, and you have the stress of the day on you and stuff like that, so it's pretty annoying. Sometimes it's like, I gotta go do this thing, and it's always fun when I get here, but sometimes it's not fun before that. What? This is not the correct resolution. Let's see. Host F. All right, there we go. That's the correct resolution. So yeah, that's pretty cool. I'll definitely try to check you out this maybe not this Saturday. Actually, maybe I will. This Saturday might be the only Saturday I can check you out. Because again, Saturday is also the all-day live coders conference. There will be people from the live coders team here all day. They actually have a spot on the front, like when you first get on Twitch and they show you that random, they're playing a random stream. Live Coders Conf has that spotlight for the entire day, which is great. I go on at like 12:25, I think 12:25, 12:30, and again, my talk will be it'll be a journey into DevOps. What is it called? It's called DevOps Will Do It Live, movie trailer edition. So it's going to be, again, it's going to be fun. It's going to be a little ambitious. I've been going through it and practicing. It takes a little bit of orchestration to do it, but it's basically going to be a journey through DevOps, seeing an entire pipeline, but also learning about what DevOps is like while seeing it, but also getting excited about each piece, through movie trailers. It's going to be exciting. It's going to be pretty fun. So it'll be pretty dope. I'll be watching as much as I can that day. I'll be gone for a few hours, but I think it's going to be pretty exciting. This is definitely my most ambitious talk yet. I hope I'm gonna be practicing a lot tomorrow and a lot Friday. So we'll see. We'll see how it goes. I think it'll go well. All right, we're back in. let's move over to our second problem. So the first one, we got knocked out of the park. We're the best doers ever. We are the best at singing Baby Shark. But now we are moving over to problem number 2, and this is going to get a little more normal, not quite as fun, unfortunately, but a good it's going to be a good practice problem. It starts to get into the normalcies of algorithms and like the things that as you're going through your career that you're probably going to have to learn, that you're probably going to have to do, which is going to be kind of annoying. So we're going to be fibbing all of the Nachis. Now, I don't know if any, like those, I hope neither one of those is some type of slang term that I don't know about, and I just said terrible things. But all I did was split up the word Fibonacci sequence. So we'll be fibbing all the Nachis, and hopefully it's fine. But if not, oh well, I apologize. But a bit more serious this time. We're going to see if we can write an algorithm to print out the Fibonacci sequence up to a number that we choose. Now, if you have no idea what Fibonacci sequence is, again, it's a mathematical equation. Actually, I think it has something to do with like the law of I've read some interesting things about it before, but like years ago. But all it really is, it's a sequence of numbers, and it's basically taking the two previous numbers and adding them together, and that's how you get the next number. So 0 plus 1, you start at 0, from 0 to 1, and then you add those two things together, and when you add 0 and 1 together, you get 1. And then when you add 1 and 1 together, you get 2. And when you add 2 and 1 together, you get 3. 3 and 2 together, you get 5, and so on up the ladder. And so this is a common base of a lot of the more advanced algorithms. So again, when we're talking about these, all those data structures, all those linked lists, and traversing binary trees, and doing all the crazy stuff that you can do when you're solving algorithms, and you're talking about all those things, I've seen a lot of problems that will use something similar to the Fibonacci sequence to understanding the concepts necessary to be able to calculate this are beneficial long term. And now there's a million ways, there's not a million ways, there's one standard way to do this, generally using recursion. We're not going to use recursion tonight. And why aren't we going to use recursion tonight? Again, I think it's confusing, and I think from where we're at, we haven't practiced a lot of problems. And so I think, again, just using the tools, just thinking through what we have to do, I think is a good practice. Maybe when we're done, maybe if we finish everything, we can go back and optimize and see what it looks like when you take something from, take a look at what you have and optimize it, redo it into a way that's more structured, refactor. I don't know why I lost the word refactor there, but refactor it until it's better. You do not have to get everything right on the first try. Your application will almost never be correct on the first try. And so let's just see if we can understand the steps necessary to get the Fibonacci sequence. And kind of, I think when you go through something like this, in my mind, I think the first time I ever heard this and I tried to do it via code, I was like, oh, this is cake. This is cakewalk. If there's any problem that I can do, it's Fibonacci. And I thought it was easy, and then it was not easy, and it was very frustrating. And we'll do this one. We did that one in Python. We'll do this one in Go. Just because I think the tools that we're going to be using are going to be the same. So it's not going to be, the syntax isn't going to be wildly different at all. So just to see us do it in another language, let's check that out. So all we need to do is write some code to basically say, hey, maybe for our case, maybe we'll set a max number that we can change. And we'll say, hey, give me the Fibonacci sequence all the way up to this number. So give me all the numbers that are less than 100, or give me all the Fibonacci sequence numbers that exist before 5,000 or something like that. And we can change that and see how far it goes up. So yeah, it's pretty interesting algorithmic challenge. And I thought it would be a disservice to you again to talk about, I actually shifted this like last week because of a message someone sent me just questions they had as they were going through their things. I was like, man, there's so many things between the questions this person is asking and what they've learned so far, and someone else gave them this problem to do, and there was a huge gap of knowledge in between there. And I think a lot of it came from, again, they had all the tools necessary to possibly be able to solve this problem in a pretty inefficient way, but like that's fine, they could have still solved it. But we haven't used the tools. We picked up the tools, we didn't use them yet, so let's use them. You can't get great with the hammer. You know, your aim with the hammer doesn't get great until you start hammering some nails. Okay, so that's what we're doing here. Yep, dynamic programming, exactly. Having a little fun. Make a dinner. I appreciate you coming through Illuminate Space. You're probably already gone now, but thank you so much. Go enjoy your dinner. Okay, let's get going with a little bit of Fibonacci. And so we'll go back into deCoded, even though this is going to be Python. Actually, I mean, this is going to be Go. I think there's Go stuff in here. deCoded, and let's make a directory. Make a directory. What are we going to call this directory? We're going to call it Fibonacci. Fib. I'm not even going to put the O in there. I'm going to call it Fibonacci because yeah, it's fun. You know, we do speak a little slang over here. I appreciate the 5 bits. David Snyder, thank you so much. David Snyder 404. You're not found, but I appreciate. First off, I love the pup emoji, or is that maybe it's not a pup. It's either a pup. It's little on my screen. It could be a hamster. It could possibly be a cat, but I'm pretty sure it's a pup. I love it. It looks like the pup's howling a little bit. Thank you so much for the 5 bits. Thank you for the support. All right, so we made this Fibonacci directory. Let's head on in and let's vim Fibonacci. Well, we'll spell this right, and I don't even know if it's spelled right. Fibonacci.go. Let's do Go one, like I said, and let's have a little bit of fun here. Let's see who just gave me that follow. Zanian, thank you so much for the follow. Good to have you. Appreciate it. It's called Corgo on Twitch. Oh yes, I guess it's a corgi. Perfect. I love it. All right, so Go looks a little bit different, and so this is the main kind of Go setup, and my Vim is set up to give me this when I start a new Go file. If you are trying to follow along and you don't want to have to type that stuff in, head over to, or if you just want to follow along and play around. Oh man, I should have turned off. Darn it! This already messed me up. With new incognito, will that help? Nope, that's done for. Let's go to Firefox. Head over to Go Playground or to repo.it, Go Playground. But you can always grab, if you want to mess with, or like, you don't have to do it in here, but if you copy and paste this right here and Go Playground, you can copy it straight over to your text editor, so that you don't have to like remember how to type this out every time. Because again, for Go, you always need this main function and you always need something like this. So the goal here, let's delete this line. Oops. The goal here is write some code that will print the Fibonacci sequence up to a given number. Okay, that's what we're going to be doing today. All right, so what again do we have to do? Let's take a look at what we have to do again. Let's think about it a little bit. Starting at 0, we have to start from 0, and we're going to go up, and so it's basically going to be adding a number and the 2 previous numbers together. Adding a number and the number before it together to get the next number. And so maybe let's start out by printing up to our number. Maybe that's the easiest thing to do. Maybe we'll have a variable. Let's set up a variable called limit. And this is going to be whatever it goes up to. So this is going to be whatever we want. So let's start with 100, because 100 just seems like a nice, even, safe number to do this to. And let's start by just printing to 100. Now, in Python, you can use the range function. I could also do the range function works a little bit differently here. I could still use it, but it will be in a different format. I'm just going to use a for loop to at least count up to our limit and print out all the numbers up to our limit. And so we can do something like this, our counter. So we'll, for count equals 0. Actually, I can set our limit here, but I feel like I'm going to need to set that limit later. But You know what? Let's do that. Let's make it as if we were gonna do. I'm not gonna think too far ahead. I'm trying to do this while thinking, you know, again, not thinking too far ahead. So I'll set up a limit here. Nope. We actually don't need that. Let's do a count equals 0. So you're setting up your incrementer here, and while count is less than 100, actually, let's do that. While count is less than limit, we're gonna add 1 to it. And so we've seen this once before. We've seen the syntax once before, so it might be a little bit confusing. But what's gonna happen here is our limit's gonna be 100. We're setting up a for loop, and this for loop is only gonna run in the conditions in which we've set. So the first thing we have here is we have a count set up. It's basically just going to be a number that we can use to kind of track what we need to do. And then so we're setting it to 0. And then we're saying, this is where we're setting up the condition for this to run. We say count, while count is less than limit. So while this number is less than limit, which is our variable that we declared up here, go ahead and run the code that's down here, and then add 1 to I, but not I. I'm gonna add it to count. And I'm just using count here. Count is just a variable. I'm just using it because I think count is going to be a little bit easier to follow as we're going through this. And so if I want to print out all the numbers, I just go format.println count. And so this should print out the numbers 0 to 100 for me, I believe. No problem. It might print out to 99, but let's see. And we get up and we get 0 all the way to 99. And why does it only go to 99? Because we said, hey, as long as it's less than 100, go ahead and print it out. But you know, once you get to 100, 100 is not less than 100. So therefore it does not run. So if we wanted to print out to 100, we could go ahead and throw an equal sign on here. And so now we have a little loop to go through and print everything out. Maybe this loop is going to be useful for us, but that's just kind of how I think. If I have a problem, we're trying to do Fibonacci and we're going to be printing out a sequence of numbers, but we're manipulating those numbers, I'd probably start off by just to me it seems like just starting off printing out, being able to print out numbers up to our limit is probably a good start. Maybe not as we go through this here. It's always interesting writing a Fibonacci. It's interesting writing a Fibonacci sequence thing without using recursion, because after a while you get so used to doing it via recursion that like the concept otherwise is a little bit interesting. And so I'm really kind of flying blind here, and this is good. All right, so we're printing to 100, but the goal is to take the number that we're on and the number before it and add those two things together. So we start with 0, and then we have to add 1 to 0. So that's the one place where it doesn't count. So like 0 doesn't, like the rules don't really apply because there's nothing before 0. In this case, 0 is our start. This is like a signed integer or unsigned integer, basically. So it starts at 0. And so because we can't go anything else, when you're at 0, you go ahead and just add 1 when you're done to it. So we get to 1, and then now, because we have our number and we have 1 before it, now we can start adding things up. So we can take the 1 and we can take the 0, and we can add those two things together and get the third number, which is now 1 again. But we have 3 numbers now, which is nice. There is a number previous to the one that we're on now when we start at 0. So our first concern, you might say, okay, I can start doing that. I can start saying, hey, go ahead and format.println the number that we're on now is count. That's what we've been doing. And we want to add it to the number before. And you might say, how do I get to the number before? Now, from 0 to 1, you might say, oh, maybe it's count plus count, minus 1. And maybe I'll put those in parentheses or something. So it does count minus 1 first. But I think the logic checks out at first, and it might work to give you the first number or something like that, but the very first number. But once you get up to let's take this, which one's Firefox, which one's working, 0 and 1, once you get up to like 5, if I add up 5 plus 5 minus 1, that's 5 plus 4, and that's 9 and not 8. So it gets a little weird there. So you don't need to add up that, you need to add up the number that came before it. And so that starts to sound like we need to track the numbers that come before this. It feels like we need to start tracking these things, and there are a number of ways to do this. Now some of it's coming back to me. I think that most people do it in one way, and then I think that every time I did it previous to that, I did it in a different way. And so let's try both of those real quick. So sounds like we need to track numbers. And so maybe, you know, if I want to know what the previous number was, maybe I need to set up some variables to track the previous number. And so maybe I set up a variable here called prev num, previous number. And right now I'm gonna set it equal to 0. And this is the way that most people do it. This is not the way that I did it originally. And I'll show you that. I'll show you that after this, but I think this is good. I think this is good. So previous number. So we'll set a previous number. And again, variables can be changed. So this is something that we can use throughout our program. And so maybe to even show that it's not 0, maybe you just want to do, you know, let's practice some other syntax here. And I'll say var previous, I'll use the whole thing so we can know what it is. Previous number, it is an integer. Okay, cool. So we're declaring this variable, but we're not assigning it a value. And so what we can do is we can say, all right, go ahead and print out, you know, just so we can see what's happening, print out the number that you're currently on. And after you print out the number that you're currently on, go ahead and set this number to previous value. So now we can do previous num is equal to count. So now we're setting count to that, because right now when we start, that's kind of what it's going to be. Maybe that's what we want to do. You know, 1 2 3 4 5 as we go through in the beginning. But is that really what we want it to be? Our previous number needs to be the numbers that were added together. And again, 0 is kind of weird, and you might be trying to think of some fancy way to go through, and you might be thinking of some fancy way to go through and handle this first couple cases and stuff, but you don't need to do that. You don't need to do anything fancy. You could do something like this. And I remember being very surprised at seeing, maybe this is more simplistic than people usually do it, but to just see like an if statement at the top, and then you say, hey, if count is less than 1, or less than, no, we'll go less than 1 for right now. Hey, so if count is less than 1, then basically go ahead and print, or go ahead and return, I'll just go print 1, print 1. Oh, no, not print 1. If count's less than 1, not greater than 1. So when is count less than 1? It's only when it's 0. So when count is 0, so the very first time this runs, what's going to happen? Let's think about what happens the very first time it runs. We want to take the number that we're currently on and the previous number, and we want to add those two things together. But that doesn't really work for 0 because there's no previous number. And so what we can do is we can say, all right, go ahead and just print count. So the first run, if I want to print 0 because that's part of the Fibonacci sequence, I'll print that number. And when I print that number, I can just set, I can leave that here actually. After I print that, I can simply go down here and I can set previous number, for now, equal to count. Now, this don't really do anything right now. And again, this is not, you probably already think, because I'm already thinking it, this is not really gonna work. But what it will do is, when this runs the first time, it'll say, hey, count is 0 on the first run. If count is less than 1, go ahead and print count. So the first run, it will print 0, and it'll set this, and then it'll go back through. And the next time when count is 1, it won't do anything. Is 1 less than 1? No, it's not, and it won't do anything. So let's this might need to go up, but like, let's just make sure it prints the number 1 and then nothing else. It should do that and then print nothing else for the remainder of what we do. What did I do? I still feel like we're doing Python print line previous num declared, but I use, okay, so we'll do this. So basically what it said is it said, hey, you declared a variable called previous num, you never used it, and that's not allowed in Go. And if I run this now, why is it printing everything? It should not print everything. Let me go see what I did wrong there. If count is less than 1, go ahead and print count. Oh, because previous number. It's because it's previous num. It's because of this line. So what we'll do is we will uncomment. We'll use that previous num in a second. Right now, what we want to see is we want to see that, hey, it's going to print out only 1 and nothing else, or 0. Sorry, only 0 and nothing else. All right, so print out only 0 and nothing else. And again, it only did that because of what we put in here to handle. I want to handle that first case. Again, I need to handle that 0 because when it's 0, there's no previous number for us to do anything with. And so what we can do now is we can throw this previous number back in, and you'll start to see where this is going, I think. And after we print out 0, we'll go ahead and set previous num. We'll set previous num equal to count. So that'll set it to 0. Even though it's already going to be set to 0, we can set it up top and not need to do this line. But I think it's better to be a little explicit here. And then we will also break out of this loop. Not break out of the loop, but we will continue. Does anyone remember what the continue keyword does? The continue keyword says, hey, when you're going through this loop, go ahead and end this iteration right now. Don't do anything else. Don't go below this. Go ahead and end the iteration of this loop now and go to the next iteration of the loop now. So when it's 0, it'll go through, it'll print out 0 here. It'll set previous num equal to 0, and then it will move on. It won't run any code that we do underneath here at all. And so, yeah, that'll work, and it'll just kind of keep going through, and this will actually give us the exact same output that we just had. So it's all good. So that handles at least the case when it's 0. So now let's think about when it's 1. So now when it goes through once and it adds 1 to count, and count is now 1. When it says 1, we need to go through, and what do we want to do? We want to add our current number. So we want to add count, and we want to add the number before. So we want to add up count and previous num. And so let's do that real quick. Let's see if we can do that. So we're going to say print out, and maybe actually let's do that. Let's print count. Not print. I'm gonna keep forgetting that. Format.print line. We're gonna add count, which is the current number that we're on, and we're gonna add it to previous num, which is another number that is being saved. Now, on the first run, this will be fine. But what do we need to do with previous num? After we add this, we actually need to run basically this line again, or not even again, just in the second place, because once we add them together, we need to reset what that previous number is. We need to update what the previous number was, or is, not was. And so let's see what happens here. See what happens here. All right, and we scroll to the top, and we get 0. We get 1, 3, 5, 7, 9, 11, 13, 15. Okay. So this looks, it seems okay, kinda, but it seems wrong. It looks right at first. So we got 0, 1, 3, 5, but if we look here, it goes 0, 1, 1, 2, 3, 5, 8, 13. Now, just gonna work through some of the stuff with you. Just gonna work through some of the weirdness and oddities with you. Let's see, y equals and not colon equals. Does that mean initiate and assign? Yes, equals is only assigned. So you can only do, what's happening here? You can only do this one time. And after that, you have to just do a single assignment. So you can't, like, this is a shorthand for declaring and assigning, but you can only declare a variable one time. After that, you just have to assign it a value. So what's happening here? What's happening here is that we are using the wrong numbers. We are doing what we're doing what's right. We're not doing what's wrong, but we are using the incorrect numbers here. So we are adding the previous number to the count every time. The count only goes up by 1. but Fibonacci is printing out the value of the current number, not the count that it's on, the current number plus the previous number. So once you get to 3, so you add up 1 and 2 and you get 3, it's using this as a base. Even though we're at 0, 1, 2, 3, even though it's the 4th iteration of the loop, you know, the number's 3, and so it's going to add 3 and the last value to this current value, not to the count of the loop that we're on. So that's what we're doing wrong here. We are adding the count to that previous number, and instead of adding the count to that previous number, we probably need another variable, and that variable is going to be our actual Fibonacci num. So I'm going to call it fibnum. Fibnum is also an integer, and so we need to start adding to that number so we can keep up to date what it is. And instead of printing this out, I'm going to basically say, do we need to change this up here? So print count, previous num equals count. That's fine, I think, for now. And we basically need to say, all right, fibnum is now equal to the value of fibnum plus previous num. Now, what's the shorthand for this? How can we shorthand this? The way that we can shorthand this is doing this assignment operator right here. Fibnum plus equals previous number. So it's basically going to add Fibonacci number or fibnum and previous num together and assign that to the value of fibnum over here. And then we're going to go ahead and print out fibnum. I'm going to print that out. So all we're having to do right here is have a loop that loops from 0 to the limit that we have up here. That's all this is doing. And this first little block is checking for the value of 0. It's handling the case when this is 0. And then when it's not 0, it's going to go ahead and say, hey, all right, I'm going to keep track of our Fibonacci number. And I'm going to say the new Fibonacci number that we're going to use is going to be that plus the previous number that we had before it, which we were saving in this variable. And then we're going to print that out. But we also, actually, I did one too many things. Fibnum needs to be equal to... Fibnum needs previous num needs to be equal to the new fibnum. Yeah. No, it doesn't. Wait, fibnum is now equal to no, and then this needs to happen first, I think. Previous num. Let me think about this. This is where I always mess up. All right, 1 second. We have so this is going to give us our new Fibonacci number for this current iteration of the thing, which is great. But the previous number needs to be changed before. Okay, so 0. Hold on, let me think of this mentally real quick. So it runs through at 1. When it's 1, it hits here. It says, hey, is 1 less than 1? No, it's not less than 1. So don't do any of the stuff in here. But when we get down here, we're going to say, all right, then our new Fibonacci number is 1 plus the last number is 1 plus the previous number. The previous number was set in the previous run with this, and it was 0. But here, so here it's going to be 1. It's going to be 1 plus 0. Oh, no. Actually, it's not going to be... I'm gonna go 0. The one case is going to be different as well. We need to update this as well for the case when it's 1. 1's going to be interesting. But let's think through 2 real quick before we handle 1. Let's think through when it's 1 plus 1 equals 2. 2 is a valid option, so it'll skip this case when it's 2. The previous number should be 1. So our new fibnum will end up being 2. It'll end up being the current number, which is the current fibnum. It'll be what this turns into, plus the previous number. Hold on, getting a little confused here. For a second. And I think this is why I didn't like to do this way the first time. I prefer to do this creating some type of collection, because it's easier to just grab it from the collection to know what you had before this. But it's simple. I'm just, the way that my brain thinks, I'm having trouble getting through this. Let's see. We need to do 2 things. We need to tell the code what our previous number is. We need to assign that through each run. Our previous number needs to stay stagnant, and it needs to change. It needs to get set, obviously, before we move on to the next loop. So let's see this real quick. Fib num plus previous num. Previous num will be 0. Great. Prev num. What happens if we make this 2? Let me check something real quick. Make this 2. So even for 1, it needs to print out 1, and then it needs to set the previous number to the count and continue. So I think this will give us 0 and 1 properly. And then previous num will now be, hold on, let's do this. I'm brain farting right now. 0, 1, 1. Okay. Print count on the first one, 0. The second time it runs through, it'll just print 1. And so now it can start. Previous num would not be count anymore though, because previous one couldn't be count. Previous one, this is interesting. I can make the previous num 0 for both of these. This is sloppy, and I'm gonna change this. I'm definitely gonna change this. So previous num equals fib num minus previous num. The reason why that'll work only in this case, well, yes, that will work if, hold on, fib num minus, oh yeah, because it's going to be the opposite of whatever we put here. Yes, but minus previous num. Why's my brain? Hold on, I'm down real quick. Let's see. I lost myself. Count previous num equals 0. So even if I do, I don't care about what the fib num is right here, because this is fairly, this first line is always fairly easy to handle. Even if I do what the fib num is equal to, I still have to assign the previous number, to even do the previous num equals fib num minus previous num. And so let's try that real quick. How does this feel? This feels weird. This is why recursion is fun, but you still have to do the same thing. What will this give us? On the very first run, what will this give us? Count, or print count on 0. I'll probably have to set these to 0. 0 equals 0 minus 0. No problem. The problem is now moving up to 1, I think is the problem. Now it'll still print this out. Previous one is still 0. So this might work here. And then if we get up to 2, yeah, actually this might work. Let me just do this real quick. All right, this, okay, perfect. So it does handle 0 and 1 properly, and now I can use that fib num equals fib num minus. It's the exact inverse of what we have at the end when we're adding it. Makes sense, but wonder why it okay. So we get to 0. No, but that's only because it printed the 0 and the 1. So when it wasn't that anymore, it went to 2. And once it was 2, it tried to do fib num and previous num, and they're not anything. And again, I guess I could set both of these equal to 0 and not change these, because it does make sense. Not var. Actually, I didn't need to do that. I needed to do, let me change this. Equals 0. And so when it gets to 2, it's basically going to go, we need to add up basically 2 minus we need to add the current number minus the previous number, which will give us the previous number will be fib num, our current Fibonacci number, minus the okay, that's how you can set, yeah, that's how you can set prev num. So I can take this, and that's how you can set it afterwards here, which makes sense because we're adding it right here. But we also need to do one more thing. we need to 0, 1, 2 here. No equals this. This is still not, this is not gonna work. It's not gonna work because I'm trying to work this in my head. Why? Okay. So let me take a step back. Again, this is the way that I don't like to do it. I like to do this using collections because I think I've always had issues with the assignment here. Managing the two separate numbers. So you have the current number that you're on, which is basically the new Fibonacci number from the current run of the current for loop. And you also need to manage that against the previous number. I think we figured out how to grab the previous number by, at the very end, by subtracting the previous number, the current previous number from the new Fibonacci number that we calculated. We could do that, but the problem is what we don't have here is when it gets to 2, what is the previous number? The previous number when we get to 2 needs to be 1. Oh, okay. Then I don't think I need, the previous number needs to be 1 when it gets to 2. So I think I can set the previous number to count here. So when it's 0, the previous number will be 0. When it's 1, the previous number still needs to be 0, actually. So the previous number needs to be 0 for both of those counts. On the second run, the second run isn't 2. That's the problem right now. I'm thinking through the number. I'm thinking through the count and not the actual number. On the third run, the Fibonacci number is still 1. The Fibonacci number is 1, and it's not 2. The Fibonacci number is 1, and that will add the 1 and 0 and give you the 1 again. That is okay. I found where my brain is breaking. I'm getting the count confused with the actual Fibonacci number itself. Okay, all right, rein it back. I was like, I know mentally I know how to work through this, but that is where I was having my issue. So if we now which one temporarily holds the count? Count is completely separate from anything that we are the count is only going through the number of loops. The count doesn't really matter, actually. The count is only being used as a way to hit our limit. We could hard code the limit by setting this to limit and and setting the actual number right here. So the count doesn't matter for us at all. The count is just managing the number of times that this thing loops through. I actually don't even need to. I mean, I can really just do like a while true thing here, basically. Like, hey, run this no matter what until you get to the limit, and I can handle that limit inside of the function itself. That's probably the better way to do it. But we're gonna like I've already committed to this now. So we now need to handle it. The count doesn't matter, and that is part of the reason why it makes it confusing. The count doesn't matter. What matters is the current number that you're on and the number that you're adding up to, and that's the biggest deal. So when it is on the first run, not when it's 0, not when count 0, on the first run, that's how we need to be thinking. So on the very first run, this runs through, and the count is 0, and so we are using it here, but we will print out 0. The Fibonacci number is 0 here, and we could set that if we wanted to right here. So we print out 0. That is in fact the Fibonacci number. Now on the next iteration of the run, would be the Fibonacci number is now 1. This is what's interesting about it. Again, the way that gets handled, that's part of the sequence itself. It doesn't really follow the rest of the rules, and that's why we need this little bit of thing up here. So like it goes from 0 straight to 1. How does it do that? Well, it does that. It goes straight to 1, and now it's 1. So we kind of want to print out 1 again, and now the Fibonacci number is 1. The Fibonacci number is 1. And the previous number is 0. The previous number is still 0. And so I don't actually think we need to do anything with the previous number here. As long as the previous number stays 0, we don't need to do anything else because we're continuing. So we get 0, we get 1, and when we get 1, we set the previous number up here, which is still 0. I actually don't think we need this line at all. All right, so we'll continue. It'll go through on the third run, not when it's passing through 2, on the third run. The count is 2. But the Fibonacci number is 1. And so we need to be checking not for the count, we need to be checking for probably the fib num. It's fib num, the temp variable, and then assign it to previous num. Yeah, but I also think we need to be we need to be checking for fib num rather than the count. We need to be seeing what the value of the Fibonacci number is. So as long as it's less than 2, we need to be doing something. And so what we're gonna do is, if we print the count, we go ahead and print the count, it'll go 0, it will go 1, but we also need to set the fib num equal to the count. I think we need to do this. And why do I think we need to do this? I think we need to set it equal to the count because, again, first time it runs, it's already 0, no big deal. It'll stay 0 on the first run through. But the second run through, when it's 1, when fib num is 1, it'll check for fib num here. It'll print out the number 1, and now fib num will equal 1 because that's the current number that we care about. Previous number has never been touched, so it stays 0 up here. We go through the next iteration of the loop. It runs through, it says, hey, Fibonacci number is still 1. It is the Fibonacci, then we get into an infinite loop. Look at that. I'll get ourselves into an infinite loop right here, because Fibonacci, the Fibonacci number in this case will remain 1 indefinitely. It'll never change. Hold on one second. This thing is setting off all my alerts. Whoa, that's not what I meant to do. Get this out of here. Get this out of here. Let me remove this. Go right here. Hold on. But it'll get itself into an infinite loop, and I'll show you that. I'll show you that this will never stop running, I don't think. Oh, look at that. It did stop running because the number got super high. But what it's doing here is it's basically going to, if I keep setting it equal to count, the number will just become the count that it's on. So I can't do that either. What I can do is I can move over. I'm just getting the, let me go back. I'm getting the syntax for this thing that I want to do really quick. Where am I at? Okay, my bad. Move this, move this. We're back in action. Way less brain fart solution. Store fib num to a temp variable and then assign it to previous num. So you're saying fib num, assign it to a temporary variable. So fib num is is a variable, and you're saying assign fib num to previous num at the very end of I'm assuming it would have to be at the very end, Matt Peanut, is what you're saying. But we still need to handle, again, what happens if it is 0 or if it is 1. But let's do this instead, because I want to make this work, but I want to see if I can apply, like, my brain is really not comprehending what to do here. So let's do this real quick. Let's do our fib nums. Let's make a collection of fib nums real quick. I just want to see if I can apply I want to see if going through this is going to help me figure that part out. So I'm gonna make a collection of ints. What is it? A collection of ints. And instead of doing this, I'm gonna say, hey, while it's less than 2, go ahead and print out. I'm not even gonna print some things out. I just wanna stick them into here real quick, super quick. So I'm gonna do fib nums dot append. I'm just gonna put together a collection really quick for this, and then we will go back and do it this way, because I think this is the way, like I said, that most people do it, and I think I've always struggled with this way. Fib nums dot append, and if I want to append anything to fib nums, I need to add the count. I think is what I need here. So it'll put in 0. It'll put in 0 the first time. It'll put in 1 the second time. Even when the count is 2. Whoa, look at that. I didn't mean to spell that. But count even when the count is 1 for 0 and 1, it will do 0 and 1. Okay, and it will add a 0 and then it'll add a 1, and then what it'll do, perfect, this is why it makes, okay, this makes a little more sense to me. So watch this real quick and we'll go back and change this. And so when we get 0 and 1 the first time, now when we're on the second run, so it'll give us 0, it'll give us 1, it'll throw those into this collection. So we'll now have a collection of 0 and we'll have a collection of 1. After we get there, we can now start to add those two things together. So instead of fibnum having a one, we don't even need a fibnum here. What we'll basically have is we will add up the two things. Basically we're gonna print out basically the two options here. So we're gonna print fibnums fibnums basically of count plus fibnums of count minus 1. And so this is going to be using the index space. This is going to be using the index space here. And now I'm just going to print out the entirety of fibnum. So now I don't need to track, at least this way, I don't think I need to track anything. And so let's see what happens when I run this real quick. And if I print out just fibnums up here, let's see let's see if this works. Okay, missing before new line, line 46, 18, missing before new line. In arguments list, I'm missing some things here. Let's see. Oh, that is for 1, this right here. Fibnums not append. Continue. Count. My only problem, yeah. Defined, oh, not print, format.print line. I'm gonna mess that up every time. And format.print line. And it says fibnums. What did I type something wrong? Undefined fibnums on all of these. Oh, did I call this out wrong? Fibnums. Did I do that right? Hold on. Let's go to go by example to do an empty go by example to do an empty slice really quick. Slices. I could do it like this instead, I guess. That's never how I do it though. Well, let's see. Super confused on what fibnums is. Yeah, so fibnums is, I can change the name of that. Fibnums is a collection of it's a collection of Fibonacci numbers. So what the actual Fibonacci numbers are, so I can make that 0 first. So Fibonacci, I don't know, it's probably only supposed to be 1B there, but it is the collection of Fibonacci numbers. So rather than just printing them out, I'm going to make a collection of them to track them. I can still print them out, but Fibonacci nums is what that is. So Fibonacci nums and Fibonacci nums, whoops. All right, and the last one. Okay, so yeah, it's simply an array. It's a list, as if we were going to do this something else. So let's see. Fibnums is super confusing with fibnums. Yep, just an array of numbers. Fib. Where am I still? 14. Still using fibnums and undefined Fibonacci nums. Oh, dumb. This is why I didn't declare it properly. Just walrus operator. And where am I still using fibnums at? I said fibnums somewhere. Oh yeah, right here. All right. So now I think this will work. Type string has no field. Oh, that's not a string. These are supposed to be integers. There's no field. What? Hold on. Has no method append. Definitely has a method append. Let's see. If find go append to slice. Put it into a slice. Yeah. Oh, it's just append. I did that wrong. I called it a method like we were doing Python. Just getting a little brain fart because I'm frustrated because I'm like, I'm trying to understand, like I understand what we're doing. I just, my mind mentally can't get around the following of the two numbers. And okay, so this is simply going to be out of range. Cool, we're really close now. So index out of range, so it's basically saying when it gets to 1, it's saying these things are out of range. Oh, so it's going to be range -1. So it's going to be range -1. It's going to be count -1 because again, when the count is 2, the count is 2. Actually, is that right? Let's see. Is it this? Oh, take a look at this real quick, just so you can kind of see how it's coming along. Take a look how it printed out right here. It printed out 0 and it printed out 1. It printed out 1 originally. We can remove that print statement, but it printed out our collection here. It printed out the collections of 0 and runs. And then it said index out of range when we got to 2 with length of 2. So there are only 2 things there, but it did not, we were out of range because we went down, I think, to -2. So let's think about that a little bit. So we did, in fact, we printed 1 once. Why did we print that? Oh, because we don't need this line right here. Oh, because we're pending it. We're not actually we didn't do this down below. So let's copy this. Let's yank this. We need to do this elsewhere. And then we actually need to calculate our Fibonacci num first. So to take that, we need to take this. This is the function that we're actually using to like add our things together, and this is wrong. We need to change it, but we need to escape. We need to take all this, and we need to actually create kind of our new number. So we're gonna say new fib, like our new Fibonacci number is going to really be equal to, it's going to really be equal to this. So it's basically going to be taking the current count item, and I think -1 is what we need. And we're actually going to be appending, instead, we're going to be appending that new fib number here. And let's see if this works. So we're creating our new Fibonacci number. We're basically taking the current number and the one previous to it in that collection, and we're going to append it to Fibonacci nums, and we're going to print out Fibonacci nums and undefined new fib. Makes sense. This is why you don't cowboy program like this. Index out of range with length 2, so just simply an out of range option here. And so 0, it's 1, it's going to have the length of 2. When it gets to 2, it's count -1. I believe this feels right now. All right, so here we go. And we got a bunch of different outputs. It's more than you would expect, but this is the collection. We printed it out in the wrong place, but take a look at the last one. I know it's confusing, but we get 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. So if we look at the actual Fibonacci sequence, in the side of here where I can actually see it, we'll see that these numbers are the same numbers. So we are getting the right numbers. 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 34, 55, 89. So we are getting those. And again, I'll change the output in a second, but that is how my mind works a little bit in following those numbers. It is using that collection. Now let's take this real quick because I really want to make this work in the way that people generally make it work. Set a reasonable limit, no, the easier way to do that is to not do this part right here. The easier way to do this is to do this right here, to only see And I will set a smaller limit as well though, but whoops. I is to print Fibonacci nums. That's what I want to print. And we will set a smaller limit, like 10. And it's not, and we're doing it incorrectly for the limit as well. It's not only going up to 10, it's running through 10 iterations of the loop. So it's running through the first 10 Fibonacci numbers, which is not the things that are less than 10. So we'll clear this actually. I did it again with the print format dot print line. And this will make it a little bit easier to see what is happening. So we get this array of 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55. So this is basically a slice of length 10. I know your brain hurts. I'm sorry. And my brain hurts. So I took a different route, which was unfortunate, but I only wanted to get here really fast so that we could backtrack really quick and maybe go through more slowly what the other solution is, the original solution that we were trying to go over. So this helps me. This is how I think. I think a little bit better like this. So all we did this way was, again, use a collection. So this collection is an ordered list of things. Whoa. And so I can use the index of the items to determine what the previous number was. The previous number is always going to be the thing at the index -1. But if we're doing this by tracking the previous number and the current Fibonacci number instead, let me see if I can modify this to make it work. I may fail miserably, but maybe we can go a little bit slower here and work through it more slowly. So we'll keep this for a loop in place. Let me see. What's happening here? I want to go back up to Firefox. This is what I want. What is it? Go infinite loop. I think I can just do for true. I believe I can just do for true. Oh, just for. Sorry, not just for true. All right, so let's do that instead. Let's just do the for, and let's handle it differently. So I'm gonna actually comment out all of this, and the fastest way to do that is going to be to do Control V. Wait. Shift B, Control. Whoa. Oh, shoot. And then I'm gonna try. Okay. Let's start over. Let's simply do for, and let's start an infinite loop here. And we're gonna say for and I still think we need a thing here. I still think we need a handler for the 0 and the 1. And we're gonna say, hey, if let's be real explicit here. Let's say if let's be really explicit just so I can understand what's happening. So I'm gonna say if fibnum equals 0, I'm gonna say go ahead and go ahead and print fibnum, and then go ahead and explicitly make previous num equal to fibnum. All right, and then I'm going to say go ahead and continue to the next iteration of the loop. All right, so I'm handling the case when it's 0, and I'm going to handle these cases explicitly, and then I'm going to change them so it's easier. So it's going to run through that. If it matches, it's going to go ahead and do that. I'm going to say I don't really need to do an else here. If that's not true, that block of code will not run. So I'm going to say if fibnum is equal to 1. All right, what happens when it's 1? If it's 1, we do want it to print out fibnum. And we want previous num. Previous num when it's 1 is still equal to 0. Or is it? The first iteration is 1. previous num now, if previous num now becomes 1, the next run fib num. Okay, so I think that is what we want. I think that's where I was going astray. Previous num is now fib num, so now previous num is now 1, and we want it to continue. I want that to continue. All right, so if it hits that case, and we need to close this up real quick and put a little space here, and we need to close this up real quick and give it a little space. Okay, so if it's not 1, then it's 2. All right, and so now I don't think we need to handle any other cases. So now fib num is 1. Now we can do basically see. And this is where the problem gets weird, because right now, if we are on the next iteration and fib num is equal to 1, there's 0 got printed, 1 got printed. The next case is 1 is basically fib num plus the previous num, which right now the previous num is also 1, and then you get 2, and that is incorrect. And I think the problem is I have to set fib num equal to 0 here as well, but I don't change previous num at all. So now on the next iteration, fib num is still 1, and now I can add up see, I think this is where I'm confused. Yeah, let me check out your JS solution so I can understand. I was trying to do it without looking it up, but since you all did it, let me check that out, and we can put this on the screen here. All right, so we did if limit equals 0, return index 0. So I think you did the same on a, so you did the same thing that I did. Yes, you did it the way that I like people to do it, or at least the way that mine works, not the way that my mind, I mean, not the way that I like people to do it, but the way that my mind works. You did it using no, interesting, you did a combination of them. This is very interesting. I like this a lot, actually. So you set previous number equal to 0, you set Fibonacci number equal to 1, you let result equal 0 and 1, you push them all into, got it. Interesting. So you did a hybrid approach to what I did before and what I'm doing now, and you still tracked the current Fibonacci number, and you still tracked the previous number, but you still collected them into a collection, and you use those. So let me see, hold on, where'd my chat go? Sorry, if y'all are chatting, it's here. So I need to move this back. I pulled that off. Okay, so that makes sense. But the problem is, let me look back at your solution again. Why, I wonder just why this is breaking my brain so bad. Why, when it's 1, for count equals 1, while count is less than limit, count plus plus, start a count at 1. Okay, that's interesting. That'll do it. Starting count right at 1. Oh, okay, so you started count right at 1, and you already had 0 in your collection. So yes, that's how you handle that. And that's basically what I'm trying to handle here, to be 100% honest. After I handle this, I think it's relatively straightforward, and I think it's just like the problem that we already did. And so maybe I'll just say, let's do this. Limit, let's do a count here as well, just for my own, just to appease me. And again, this could go back to the for loop, but just so it's a little more explicit. And let's do count plus plus, same thing here, count plus plus. I don't think I need to set this, so it's going to print out 0, then it's going to print out 1, and then maybe, you know what, maybe okay, I'll do what you just did, in the same ways, is in like explicitly code out those things. So I'll set previous num equal to 0, and I'll set fib num equal to 1, and so 0 and 1 will print that out. And I don't even think I need to count here anymore, but if I don't do anything with them, I'll go ahead and just print out and I don't need both of those if statements anymore. I could just change it. I could merge those into one. But then after that, because I have fibnum set to 1 and previous num set, then this is where you can now do the same thing that you did. So you can do fibnum is now plus equals previous num. Is that what I know? Yeah, prev num. That's what you have here. That makes sense. And then I need to set prev num now is now was it minus? Can I just do minus equals as well? Previous num minus equals fib num. And I think count plus plus. Yeah, this is dumb. I should change this into let's see, for count equals 0, back to what I had it before, while count is less than limit count. All right, so I think this will work, and I can combine these into one line to be 100% honest. And I don't need this line either. Let's see if this works. Fibonacci nums on line 37. Oh, whoops. I forgot there was more of the application below here. Three, 8. Woo, I did every single one of these wrong. Wait, actually, is every print in here? All right, let's do some vim foo real quick. Slash s slash print slash format dot print line slash g. Wait, was it slash, or is it, oh, it's percent s slash print slash dash g. This feels, yeah, look at that. That was a global find and replace right there. You know, off the top of the dome. Is this NeoVim? I don't think this is NeoVim. Oh yes, this is NeoVim. This is NeoVim. It is. You can use the same vimrc. It just needs to go in a different place. It needs to be your init.vim instead. Oh, there we go. So far I got format.println. That worked. Counts is declared but not used. Right here. Just cleaning up my code. And we got 1, and then we got 1 again. So I never printed out 0. If count is equal to 0, oh, print, you know what? I'm just gonna manually handle it. Actually print count. And let's just change this to, well, count is less than 2. Go ahead and print that. And we can delete this whole line right here because they do the same. This is the same thing that it's doing here. We get 0, we get 1. Okay. And the reason why it only prints that is because we are not printing out anything down here. To see it, I will say go ahead and print out fibnum so we can actually see it. It's running the code. I don't know if it's right, but we can't see it. Ooh, 0, 1, 1, 0, -1, -1, 0, 1, 1, 0. Oh, interesting. Okay, so I really just grabbed what we had from this solution here. And so we try to do fibnum plus equals previous num, and then previous num minus equals fib. Oh, okay, previous num is not minus equals fibnum. It is actually different. It is, whoa, where did that, darn it, I lost it. Previous num is fibnum minus previous num, I think is what, I think that's what it's supposed to be instead. And there we go. And that looks more like it. So I just implemented that wrong. So this makes a little more sense to me. It's still, well, it doesn't. I still manually handle this, and I guess I'm wondering what people usually do to handle this first case. And I think that's what was so confusing to me. And what I'm going to do to check it is, I want to like this. See, doesn't it see? I guess this seems too like savage. Like it feels very like it feels savage. So let's see. Go Fibonacci example. No, not high performance. I want the simplest one that we have that we can have. Let's see what they have here. And so they're probably gonna go recursion first. Yep, recursion first. And so what is recursion? Again, recursion is actually having a function basically call itself. So look at this. Fibonacci, we're defining a function up here, but look, it returns it basically returns a calculated value where it uses or it's calling itself to be able to calculate things, which is very interesting. So recursion is the kind of de facto right way to do specifically this. I'm hoping they give me a different option with slices and loops. Okay, let's see what we have here. This looks like okay, they did what I did. All right, but did they do okay, they did it how I did it. Well then, and okay. First, oh no, okay, here we go. This person is doing it differently. First, second, yeah, I don't know. I just don't know how to handle the 0 and the 1. It just really feels, it feels like there's no good way to handle. This does not feel wrong to anybody else. I don't know. So it makes sense to me this way. It does make more sense to me this way. How did I handle that before? Oh yeah, before it was easy because I guess I was doing the exact same thing. I really was doing the exact same thing. I guess because I was doing like an append here. Again, I felt like I was doing something a little more important. I felt like I was doing something, programmery, rather than just printing it out up here. So I guess it's the same thing. But that really threw me for a loop, to be honest. That was really confusing. But that took up all our time. We didn't get to make it to the third option. But I know that was confusing for you. I promise you that if we would have dove into linked lists, and if we would have dove into various other types of data structures, and if we would have started talking about big O notation and all that stuff, it would have and done actual problems with it, it would have been equally, if not much more, confusing. And I apologize because a lot of that was me getting frustrated and trying to understand why I was so confused. But what I hope you got out of that was one, to see that I abandoned one process to try to hold other process to help me understand this process right here. I also used someone else's example to help kind of guide me a little bit. I should have done that earlier, but I kind of wanted to, again, for my own benefit, like really think through some of the things and see if I could wrap my mind around the way this works. I cannot tell you how many times you're going to be working on a problem where it's difficult for you to solve, not necessarily because you don't know how to solve it, but because the way that you are thinking about it, the way that your brain works, you haven't been able to frame yourself to come to that certain solution. We come to stuff like this all the time on our project now. Like I think very differently from the developers on my team, and we're able to kind of solve each other's problems when we run into roadblocks because just coming at it from a completely different angle, and the way that we think through things, and it can be valuable. So part of the process of getting really good is being able to see these problems from all those different angles. And that's one of the reasons why I was like, I really want to understand how to do this using it's not that different of a concept. Like, you're just assigning some variables, but like my brain could not follow which one was supposed to be which and where, but it's all good. It is all good. But I would look into the Fibonacci sequence. Is, again, it's a fairly simple sequence of numbers, but calculating it, as you can see, can be a little interesting. I would check out, a lot of the things you're going to come across if you Google it is going to be recursion. and it can be frustrating. Recursion can be very frustrating. So I'm not telling you to go there yet. I'm telling you to do more of what we just did and kind of brute force your way to a solution. That's not the right way, but it is, I think, the most beneficial way when you're first learning how to solve some of these problems. I'm gonna push this up as well with both of the. Here's what I'll do. I'll take this out and I'll put this in a separate file so you can see that they're almost the same, to be honest. Excuse me. Yeah, they're almost the same. And I always forget how to do this. Add child node, fib collection dot go. Let's open up fib collection dot go, and the only thing is I don't know how to uncomment. I don't know how to bulk uncomment. It does not work the same way, at least in my experience so far. It does not work the same way. As bulk commenting. It's very frustrating, but I'll figure it out one day. And we need all the same stuff up at the top. So we need package main. We need to import fumped. We need to func main. We're gonna open this up. We're gonna close this at the bottom. And yeah, stuck it all in there for us. Let's see if both of these work. This one I'll have to print format.print line Fibonacci nums. All right, I think this will run. So go run Fibonacci still works, and Fibonacci fib underscore collection. Whoops. Oh, lots of problems here. Limit. All right, I'll fix this before I push it. But just to show you the two different ways of how we got this stuff out here, and the ways that we implemented these things here. So we only got through two problems tonight. So one, that shows you how long sometimes these take, especially when it took us an entire hour to get through learning how to do Baby Shark. I hope that you enjoyed the Baby Shark section of the course tonight. Again, I thought it was a good, primer, a good kind of start. You can also see here, notice how even though we're using a different language, we didn't use any tools here besides append, I guess, that we didn't use any new tools here on what is considered to be I think it's a harder problem. We didn't have to use any extra tools. We used to use the same tools that we do before. We used a loop. We used a for loop. We printed out some stuff. We added some things together. And so, we didn't do anything crazy in any of these, but it still got to be pretty confusing. So hopefully you can start to see how you can use the same tools over and over again to get to certain outcomes. You'll start to see paradigms of loops plus other things and different ways that are commonly used to get to intended solutions. As you start to hear more problems, as you start to break them down, you'll start to immediately, rather than knowing what to do exactly, you'll start to understand solutions immediately. Once you understand the problem, you'll start to say, okay, I need to it looks like I need to take this collection, I need to perform a function on all of them. So maybe I need to do some type of list comprehension, or maybe, pretty easy, I can set up a, list comprehension, or I can do, I can run this loop here that's going to add these things together, and it helps you get there. But yeah, if the limit is 10, the last number should be 55. I think you have 34. And that is because it is only counting up to, which one is, that's because it's only counting up to the limit, and not including the limit. If we include the limit, I think you are correct. And you are correct. There we go. you know, simple comparison operator we need to include, so it does in fact go up to 55 now. But there we go. The last thing we were going to do tonight, which I encourage you to go try on your own, and we can do it one day. The last thing, oh man, this is like, you know what, I forgot that I'm also showing this, so I can go here. I'm showing my desktop instead of just the, what? Where did that just go? Hold on, there we go. The last thing we were going to go over was going to be Scrabble with words with friends. So there is an exorcism. If you go to your exorcism page, there is in fact a Scrabble exercise, and I think it's a pretty interesting one because it's going to dive into the next it's going to dive into some things that we haven't really practiced with. I'm going to give you a hint already. You can use a dictionary or a map to do this, but it's basically going to be a way for you to pass in words and calculate the value of that word in a Scrabble game. So it's a pretty interesting one. It will take you, it'll probably take you, it says it's easy. I don't think this is super easy. It is easy, but when you're learning, I think this is actually very difficult, to be honest. There are a lot of moving pieces here. And yeah, I think it's a valuable one to kind of really stretch the skills that we've learned so far. Again, it doesn't take anything new or fancy to be able to do it. I would almost recommend, again, we haven't done test-driven development yet, which we're going to be doing on Thursday. And I almost recommend, that's why I said find the Scrabble problem exorcism to work off of. I would almost, well, not almost, I encourage you to not do, at least right now, if you don't really understand the paradigm of the way that you can use the TDD stuff to solve your programs, again, which you'll learn on Thursday, I highly advise you try to just make your own little application without using their subcode, because I think you'll be more confused about where to go and the direction to go, even though it's intended to be there to help you, to help guide you. I think in the beginning it's very frustrating to do. But yeah, that's it for tonight. Right on time, right on time. By saying we're being right on time, we're 6 minutes late, but no big deal. Yeah, I hope that was fun. I hope that you are not afraid of problems now. I hope that you're like, all right, cool. We struggle through some problems. I can go do some problems now. Whether you do them successfully or not a big deal. I just encourage you to go through and try them out yourselves and have a little bit of fun. Even if you get nowhere, like the practice of just thinking through what you're possibly going to do and trying out things and seeing how the program interacts. And when I see errors, so we saw a lot of errors tonight that I immediately saw, and I immediately went to go change something. And you might have been like, yo, what? Well, first off, how does he know what's wrong? And so it tells you these are things that you'll learn from doing. I've seen so many errors that I can immediately identify one and likely what's wrong because I've experienced so many of them. And so again, it's part of the process. It's simply going through and doing that. But any questions? That's it for tonight. Does anyone have any other questions about what we did tonight? I do. I'm putting this in the classroom because this is a good one. That took a long time. Google Classroom. You made me think my internet was down. All right, decoded classwork. Let's create. Try this exclamation point. Actually, I probably should just add this as a link instead. Oh, it's gonna have you. Oh, okay. Wait. Actually, how do I share just this? Why does this say solutions? Python track. Can you share? Push hello world. Interesting. I don't know if I can share it, but it's Scrabble score. Actually, I'll just give you this then, so that you can copy it and you can check it out. In case that doesn't work, I will also add this link. Not this link. I will just paste this here. There we go. Post that under algorithms and we're good to go. But that's it. We got in some practice tonight. We're back again on Thursday with TDD, test driven development. So we're going to learn how we can use tests to guide our development. You might say, how can we test something that doesn't exist yet? Yeah, we'll get there. We'll write the test first, we'll write the code after, and we'll learn all about how that's done. If you're interested in anything going on in the Horizons course, tomorrow we're doing systems manager, billing, and CloudWatch systems manager and billing. So it's going to be kind of a lot of things that we've already kind of touched, but kind of learning a little bit about monitoring, how to find out information about what's going on in the systems, as well as your account. Yeah, that's it for the week, and then we'll be done with week 7. And then next week we have 2 panels, so keep your dates open for Wednesday and Thursday of next week. Wednesday will be the Horizons panel, which is going to be some people from we're gonna have one person from AWS and a few other engineers who work with the cloud. Come ask your questions. We'll be around again for 2.5 hours to ask whatever questions you want to ask. And on Thursday of next week we will be doing one here as well with software engineers, and you'll be able to ask whatever, for the most part nothing's off the table, nothing non super personal about someone's like personal life, but about someone's career. We've talked about a lot of different things. We've been pretty transparent in the past about salaries. We've been pretty transparent about how we felt about job hopping, all kinds of stuff. So come with your questions. I think it'll be pretty dope. I think both of those nights will be pretty fun. But that's it. That is it. So who are we rating tonight? Or does anyone have any questions? If you have any questions, feel free to ask away. And if not, we'll head over to Kid Quebs, because we haven't been over to Kid Quebs in a while. And looks like he's doing some building a cool application, so we can maybe apply some of the things that we learned tonight. Maybe you can watch him build some things and see what's going on over there. Actually, no, we're over there. Appreciate that, Sean. Good to see you. What was I gonna say? I feel like there's something I'm supposed to tell you all, but I don't remember, so it's not important. And if it is important, I'll remember as soon as this is over, and I'll have to save it until Thursday. It'll be fine. We'll all survive it. But yeah, let's head over to Kid Quebs and say hello. I'm gonna go. I do have news for you, but I'll wait. I will wait. I have more specifics on some dates of some things, but I will wait. Well, let's go. All right, MJ, and see you later. Everyone have an excellent night. Rest up. Come back tomorrow for Horizons. We're almost there. You have a week and a half left. Almost there for this iteration. But peace out. We're out here in 10 seconds, 9 seconds, 8 seconds, 7 seconds, 6 seconds, 5 seconds, 4 seconds, 3 seconds, 2 seconds, 1 second. Let's go.